Good morning students, myself Manuj Kumar Agarwal, Assistant Professor from MIT Muradabad. I heartily welcome to all of you in the online courses launched by AKTU, which is MOOC. In the current session we will discuss about the laser application, because laser is going very much famous nowadays. Why it is so that we can see the laser application in different fields. If we go in the communication, laser is being used in DVD drive, CD drive. Laser is also being used in optical fiber applications. If we see that, we are also seeing the toys which are being used by the laser, such as laser torch. Laser pointer is also there. In the medical line, if we see that laser is being used to remove the tattoo, we can also see that the laser is also being used for the treatment of the cancer. Laser is also being used for LASIK operation, and as well as we can also use the laser to remove the hairs from the body. So, there are various applications of the laser in general life. That why laser is being much and much popular in today's life and attracting the researchers towards itself. So, in the current world of laser, first of all we will see what is laser. Laser kya hai? What is laser, and first of all in that topic we will discuss the acronym of laser, and after that we will discuss the definition, and we will try to correlate the definition with the acronym of the laser. The second topic which we will discuss, that is basic theory of laser, which is based on atomic structure. All of us are aware about the atoms, and so we will discuss what is atom, about how the atom is designed, and atomic structure. The third one is laser characteristic, as we see that today much and much laser is being popular nowadays. So, why it is so? It is only due to the characteristics of laser. The third one is the process which is spontaneous emission and stimulated emission, by which laser is being generated, and in last we will discuss what are the Einstein coefficients, and we will try to correlate these coefficients, what is the relation in these coefficients. So, very first we will discuss about what is the laser. As we see about the laser, the full form of the laser is light amplification. Why? Light amplification by light amplification by stimulated emission of radiation. Means we want to amplify, we want to increase the intensity of light, because if we are saying about the ordinary light, the intensity of the ordinary light is very low. So, it does not have any practical use. So, we want to increase the intensity of light, and how can we increase the intensity of light? We can increase the intensity of light by using the process of stimulated emission of radiation. Means the process which will be applied, that is stimulated emission. We will also discuss about what is stimulated emission in the next topic. So, how can we describe the laser? If we want to describe a laser, the laser is described as the process that generates intense beam of light, as we have seen in the full form of the laser, amplified. So, intense beam of light which is coherent, this is the properties of the light, monochromatic, and how we will generate this light? We will generate this light by stimulated emission of photons. And where are these photons? These photons are in the excited state. So, from the excited atoms of molecule. So, we have seen that the acronym of the laser and the definition of the laser are correlated with each other, or we can say they both are the complementary of each other. So, before going further that about the first laser, we will see the history of the laser, that the very first Einstein put the postulate of stimulated emission in 1906, and in 1954 H. Towns and his co-workers tried to put this postulate of Einstein in the practical realization, but the very first laser was given by T.H. Mahiman in 1960. So we can say that बीज बोया किसी ने, फल खाए किसी ने, मीन्स सारा प्रोसेस तो आइंस्टीन ने किया था, बट जो इसका प्रोसेस निकल के आया, जो इन्वेंशन निकल के आया, वो वेरी फर्स्ट इन्वेंशन वाज गिवन बाय द T.H. Mahiman so in 1960. So next we will discuss that what is light. Light is made up of very small particles that are called photons, and from light comes from the atoms. So what is atom? As we have seen earlier, we have in the previous classes that atom has a structure which has a nucleus and electrons revolving around the nucleus. So we can say that atom is composed by nucleus and the charged particle electrons, and nucleus is also confined, is also made up of protons and neutrons. Proton has the positive charge, so it is called the positive charge particle. Neutron has no charge, so it is called neutral particles, and because the nucleus is composed by proton and neutron, so nucleus will have the charge of the proton, so it is also positively charged, and negatively electrons are negatively charged, so they are called the negatively charged particles, and due to the attraction force between the nucleus and electrons, electrons revolves around the nucleus in the circular orbit, or we can say that in definite orbits. सो इलेक्ट्रॉन्स के लिए, हर इलेक्ट्रॉन्स के लिए एक निश्चित ऑर्बिट होता है जिसमें वो रिवॉल्व करता है. सो दीज ऑर्बिट्स आर आल्सो नोन एज द एनर्जी लेवल्स. सो द एनर्जी लेवल विच इज नियर द न्यूक्लियस इज नोन एज lower energy level, and the energy level which is far from the nucleus, it is known as higher energy level, and the atoms which want to excite from the lower energy level to the higher energy level need some energy to excite from the lower energy level to the excited state, and but जो ऊपर गया है उसे नीचे भी आना है. So Einstein put his postulate in 1917 that the particles comes to the ground state by releasing the photon by using the two process. The very first process is spontaneous emission. The second postulate is stimulated emission. It can employ either spontaneous emission or stimulated emission. इन दोनों प्रोसेस में से कोई सा भी प्रोसेस करके जो एटम एक्साइटेड स्टेट में है वो ग्राउंड स्टेट में वापस आ सकता है. सो वी हैव सीन दैट ऑल द प्रोसेस दैट वी हैव टू यूज. नाउ व्हाई वी आर सीइंग दैट व्हाई द लेजर इज सो मच पॉपुलर. द लेजर इज टू मच पॉपुलर ओनली ड्यू टू इट्स यूनिक कैरेक्टरिस्टिक्स, in which very first characteristic is monochromaticity, the second characteristic is directionality, and the third one which is last is coherency. The coherency is much useful, although all the properties are useful, but coherency is the much useful. Directionality is also useful, monochromaticity is also useful, but the coherency is much useful. So very first we will discuss about the very first property, very first characteristic of the laser, which is monochromaticity. The monochromaticity refers to the light which has only single wavelength, means laser has only single wavelength. If we compare it with the ordinary light is composed with a mixture of the wavelengths. So as we can see here in the graph that this is the laser light in a narrow beam, and this light is for हाँ हाँ, अच्छा अच्छा, यहाँ तक सही गया है? कितनी देर की हुई? 10 मिनट की भी हो गई यहाँ तक? नहीं,
ये था ना,
हाँ मोनोक्रोमेटिसिटी।
यहाँ से कर लीजिए।
तो ऐसे ही बोलना स्टार्ट कर दूँ कुछ? So we will discuss about very first characteristics of the laser, that is monochromaticity. What is monochromaticity? Monochromaticity means जब किसी भी लाइट के अंदर या किसी भी वेव के अंदर केवल सिंगल वेवलेंथ हो, that is called monochromatic light. So monochromaticity is, so light, laser light is monochromatic light because it have only a single wavelength. And if we will talk about the ordinary light is composed by the mixture of the wavelength, as we are seeing in the graph. Here in the graph, see that laser beam is directed by a narrow beam, while if we are talking about the structure of the ordinary light, it is mixture of the wavelength, so it has broad spectrum. So that's why laser can travel a large distance in the medium in spite of the ordinary light. The second one property is, so if we see, we are seeing the comparison between the red light and the wavelength of the blue light. The crust and trough of blue light and red light are not falling on each other, so they make a broad spectrum. So now the second property is directionality. So अगर हम एक ऑर्डिनरी बल्ब को जलाएं, या हम बात करें एक सनलाइट की, जैसे ही हम लाइट को जलाते हैं तो वो लाइट चारों तरफ को फैल जाती है, मीन्स दे ट्रेवल इन मल्टी डायरेक्शन, द डायरेक्शन इज नॉट फिक्स ऑफ ऑर्डिनरी लाइट. एंड if we will talk about the laser light travel in only a single direction because it diverges only a minimum path, in the minimum path, so it can propagate at a longer path. So we can easily see that the comparison of ordinary light and laser light. So we will discuss about the third characteristic, which is much important characteristic, that is called coherency. So first of all we will have to understand what is coherent sources. Whenever the two waves are propagating in the medium which have the same frequency and same wavelength and maintaining the constancy of phase difference, then the two waves are known as to form coherent source. So laser light form the coherent source, as if we see in the figure that the crust of the light and trough of the laser light are falling to each other. So they are maintaining the constancy of phase difference and traveling in the same direction. So they are maintaining the coherent source. So we can say that laser light is a coherent source. If we will talk about the ordinary light do not make a coherent source because from the figure we can see that crust or trough and trough are not falling to each other. So they are not forming coherent source. So we can easily differentiate the ordinary light and laser light on the basis of these three characteristics. The very first is coherency, the second one is monochromatic light, and the third one is directionality. So we are seeing very first the lamp ordinary light, and the ordinary light is not a monochromatic light, it has many wavelength. The second one is multi-directional because ordinary, as well as we light the bulb, the light is started to scattered in the whole medium. So it do not maintain the single direction, and the third one is incoherent. The ordinary light is not coherent. And if we will talk about the laser, it is monochromatic, it is single directional, unidirectional, it travel in the single direction and maintain the constant phase difference. So it is called coherent source. So basic concept of the laser: first of all, whenever the light interact with the matter, then the three process comes into the light. The very first is induced absorption, the second is spontaneous emission, and the last one is stimulated emission. We will discuss briefly about the absorption, spontaneous emission and stimulated emission. As we have seen earlier that stimulated emission is is the main characteristic. हटो आ जाऊं बाहर. स्लाइड बैक कर लूं? अच्छा, कहाँ से आ गई इस वजह से? ठीक. So we will discuss about the basic concept of the laser. Means whenever a light interact with the matter, then what type of process comes into the light? The very first process is induced absorption, the second process is spontaneous emission, and the third process is stimulated emission. As we have seen in the definition of the laser, that stimulated emission is the main property of the laser or if we want to laser, then we have to understand what is the stimulated emission, because if we want to amplify the laser light, the ordinary light, then stimulated process have to come into the light. So the very first process is absorption. Means whenever an atom is in ground state and some energy from the out source is given to this atom, then this atom absorb the energy and excite it to the excited state. This is called induced absorption, because most of the atoms resides in the ground state, and whenever they absorb the energy, they have the characteristic to leave the ground state and to jump to the excited state. So on what circumstances the probability of the induced absorption depends? The probability of the induced absorption is given by N1 P12. N1 are the number of atoms in the ground state and P12 is the probability of jumping of the atoms from the ground state to the excited state, and it is equal to the N1, V12 and U nu. N1 again the number of atoms in the ground state, U nu is the energy density, or it is the function of the energy which is given to the atom which is in the ground state, and the V12 is the Einstein coefficient. Means the probability depends on the two factors. The very first factor is number of atoms in the ground state, the second factor the energy given from the out source, the third one is depends on the properties of excited state and ground state. So probability is given by this function, and we have seen that V12 is the Einstein coefficient of induced absorption. The second one process is spontaneous emission. As we have seen that the when atom absorb the energy and jumps to the excited state, it can remain in the excited state only for the timing of 10 to the power minus 8 second and jumps back to the ground state spontaneously by emitting a photon which is equal to the energy difference of excited state energy and ground state energy, and the probability of the spontaneous emission is given by N2 P21. N2 are the number of atoms in the excited state and P21 is the probability of depopulating the atoms from excited state to the ground state. On what circumstances it depends? It does not depends on the energy of the external source, because here the no external energy is given to the atom, all the process happened spontaneously. So, it does not depend on the energy of external source. So, it is equal to the number of atoms in the excited state, and A21 is the Einstein coefficient of spontaneous emission. So, we have learned about the induced absorption, spontaneous emission. Now, the third one, which is the most important process, that is called stimulated emission, means whenever the atom is in the excited state. Here we are seeing that this is the excited state, atoms in the excited state, and energy is given to this atom from the external source. Then atom absorb this energy and comes back to the ground state by emitting the two photons, one photons which the atom was having already, and the another photon which was given to the atom from the external source. These two photons are traveling, we are seeing these two photons are traveling in same direction and maintaining the constancy of phase difference. So, they form coherent source, while in the spontaneous emission in the previous slide we can see that in the previous slide, in the spontaneous emission the atoms the photons were not traveling in the same direction. So, they are not maintaining the coherency. So, that is why we say that spontaneous emission is not used in the process of the on the modulation or want to make the laser light. The stimulated emission process is widely used in the process of making the laser light. The probability of the stimulated emission depends, is given by N2P21, which is equal to the number of atoms of the excited state, energy function given to the atoms in the excited state, and V21 is the Einstein coefficient of stimulated emission. So, we can see that stimulated emission, some principle of the stimulated emission, some properties of the stimulated emission, that they are in same phase with the incident photon, they have the same wavelength of as the incident photon, and the last one is they travel in the same direction as the incident photon. So, we can say that stimulated emission process is widely used in the making of laser light in spite of the spontaneous emission, because they do not form the coherent source. So, stimulated, we have widely discussed about the stimulated emission and spontaneous emission and induced absorption, and in these three processes we have come to know that there are three types of coefficients of Einstein. The very first coefficient that we have seen, that was induced absorption, the second one was for spontaneous emission, then and the third one was for stimulated emission. So, we will try to find, we are seeing that three process which we have learned earlier, that this is induced absorption, means the photon atom is in ground state and absorb the energy and excited to the excited state. Another one is spontaneous emission, that atom is in excited state and after emitting a photon comes to the ground state. We are seeing that this photon is not propagating in the same direction as of the incident photon. So, they do not make the coherent source. And the third one is stimulated emission, in which we are seeing that when the energy is given to the atom which is in excited state, it comes back to the ground state by emitting the two photons which travel in the same direction and maintain the constancy of phase difference. So, they form coherent source. We have discussed widely these three processes. Now, we will discuss about what are the Einstein coefficients and what are the relation in between the Einstein coefficients. As we have seen earlier that the very first probability was induced absorption, in which we got the Einstein coefficient of induced absorption, that was V12. The second process we have learned about the probability of spontaneous emission, in which the probability was given by N1 P12 of spontaneous emission is equal to N2 A21, where A21 is the Einstein coefficient of spontaneous emission, and the third one the probability of stimulated emission, in which we get the Einstein coefficient of stimulated emission. Now, we will have to find out the relation in between these coefficients. So, at thermal equilibrium it was given that the total probability of absorption is equal to the total probability of emission, means जितने एटम्स नीचे से ऊपर जाएंगे एब्जॉर्ब करके, उतने ही एटम्स ऊपर से एक्साइटेड स्टेट से नीचे आएंगे एमिशन करके. सो टोटल प्रोबेबिलिटी ऑफ एब्जॉर्प्शन इज इक्वल ऑलवेज इक्वल टू द टोटल प्रोबेबिलिटी ऑफ एमिशन. So total probability of absorption is N1 P12 absorption, and total probability of emission, because there the emission consists of two process, that is spontaneous emission probability and estimated emission probability. So it is the combination of these two probabilities. Now we put the values of induced absorption, spontaneous emission and estimated emission. By this we get, by solving we get u nu is equal to A21 upon B21 1 upon N1 upon N2, which is the ratio of population of ground state and to the excited state, and the ratio of coefficient of induced absorption to the estimated emission, and minus 1. But in the thermal equilibrium B12 is always equal to V21. So by putting this value we get before putting this value we will have to understand what is the distribution of atoms in the energy levels. According to Boltzmann distribution law, the number of atoms in any energy level is given by n is equal to n naught e की power minus E upon kT. Minus E is the energy of any energy level, K is the Boltzmann constant, N naught is the initial number of atom, and T is the absolute temperature at which atom raised to the excited state. So N1 upon N2, how we will get N1 upon N2? If we put about N1, N1 is equal to N naught e की power minus E1 upon kT, because N1 is the number of atoms in the ground state and E1 is the energy of the ground state energy level. Similarly, N2 is equal to N naught e की power minus E2 upon kT, where N2 is the number of atoms in the excited state, N naught is the initial number of atoms, and E2 is the energy of the excited state. So N1 upon N2 we get, and E1 E2 minus E1 is given by h nu. So N1 upon N2 we get e की power minus h nu upon kT. So by putting this value we get u nu is equal to A21 upon B21 1 upon e की power h nu upon kT minus 1. So we get the relation, but we have to find out the ratio of spontaneous emission and estimated emission. So by comparing this relation with the Planck's law of radiation, which is given by u nu is equal to 8 pi h nu cube upon c cube 1 upon e की power h nu upon kT minus 1. So we get the ratio of spontaneous emission to estimated emission coefficient of Einstein, which is equal to 8 pi h nu cube upon c cube, or we can say that A21 upon B21 is directly proportional to nu cube. Means the Einstein coefficient of spontaneous emission to the estimated emission is directly proportional to the third power of frequency. In this way we can find out the relation in between the Einstein coefficient. Very first we have seen the Einstein coefficient relation of spontaneous induced absorption is always equal to the Einstein coefficient of estimated emission. And now we have seen that the ratio of spontaneous to estimated emission coefficient is always to the third power of frequency. So in this session we have learned about what we have learned about in this session. The very first we have learned what is the requirement in making of the general life laser in general life, what is the required process to make the laser, and after that what are the Einstein coefficient and what is the relation in between the Einstein coefficient. Thank you very much students. Have a nice day.